Hey everyone, and welcome. Today, we're going to talk about something that's really changing the game for data teams. It's called functional data engineering. Basically, it's an approach that takes all the best, most reliable ideas from modern software development and plugs them right into how we build data pipelines. Let's get into it.
So what's on the docket today? Well, first, we've got to talk about the old dilemma. The problems that held data teams back for so long. Then we'll get into the functional paradigm that's designed to fix it. We'll look at the core building blocks, see how it works in practice, and then we get to the really cool part, a concept called recomputability. It all wraps up in what you could call a DevOps moment for the entire world of data.
All right, let's dive right in. To really get why this new approach is so great, we first have to understand the pain. And for a long time, the world of data had some really big problems.
And this really gets to the heart of it all. For years, if you were a developer who needed data, the path to get it was, well, it was a mess. It was tangled, full of bottlenecks, and just frustratingly slow.
And the scale of this problem was just huge. I mean, think about this. Back in 2005, Gartner basically said that building a data warehouse was a coin toss, a 50% chance of complete failure for these massive, business-critical projects. That is just an incredible amount of wasted time, money, and effort.
And this slide just perfectly captures the tension this created. Look at this survey from 2006. A whopping 2/3 of developers were actively bypassing their own data teams. Why? Well, the second bar tells you everything you need to know. They were just too slow. The whole process was just broken.
So what you had was this huge cultural divide opening up. On one side, you had software engineering moving at light speed, build fast, break things. And on the other side, you had data management, where just adding a single column to a table could turn into weeks of meetings and approvals. They were speaking completely different languages.
So how do we fix this? Well, that brings us to the solution, a functional paradigm. This was really championed by Maxime Beauchemin, who you might know as the creator of Apache Airflow. He proposed a whole new way of thinking that directly tackles this problem by bringing those modern software principles into the world of data.
The first big idea here is reproducibility. It's a simple concept, but it's incredibly powerful. It means every single task in your pipeline is deterministic and idempotent. Now, idempotent is a bit of a fancy word, but all it really means is that if you run the same task with the same input once or 100 times, you get the exact same output. Every single time. No more surprises.
And that brings us to the second principle, which is honestly the real superpower here, recomputability. This is basically a time machine for your data. If you find a bug, or if the business logic changes, you can just go back to a specific point in the past and rerun everything to create a new, correct version of history. It's a total game changer.
Okay, so this sounds great in theory, but how does it actually work? Well, the whole foundation is built on sorting all of our data into two simple but very distinct categories.
And this is it. The whole thing really boils down to two kinds of data. On the left, you've got your entities. These are your business objects, like a user or a product. Their details can change over time. Then on the right, you have events. These are things that happened. They are facts set in stone with a timestamp, like a purchase or a click. They are immutable. They never change. And here's the magic trick that ties it all together. The central idea is that every single data table is partitioned by time. The easiest way to think about this is like a flip book. Each page in that book, each partition, is a complete, perfect snapshot of your data for one specific day.
All right, let's make this a little more concrete. Let's see what this actually looks like when we're modeling our data, starting with those entity tables we just talked about.
So here's a totally standard user table. You've got your user ID, the name, but look at that last column, DS, for date stamp. That right there is the key to this whole system. That's our partition key. It's what creates a brand new version snapshot of this entire table every single day.
Now, you've basically got two ways to build these daily snapshots. You can do it incrementally, where you just merge in the changes for that day. Or you can do a full snapshot, where you just take a complete copy of the source data every single day. Either way, you end up with that perfectly versioned history.
So, we've gone through all the setup. But why? Why do all this work? Well, this is where we get to the payoff. This is where we get that superpower we talked about. The ability to effortlessly time travel with your data. Let's walk through a scenario that gives every data engineer nightmares. You find a bug. It's been quietly messing up your data for the past 3 weeks. In the old world, this is a complete disaster. Total panic.
But with this functional approach,
The fix is, well, it's calm. It's methodical. You just follow the steps, you find the exact date the bug started, you fix the code, then you just rerun the pipeline from that day forward. And just like that, the system automatically rebuilds all the bad snapshots with the new correct data. Crisis averted.
Okay, here's another one that happens all the time. The business decides they want to change how a key metric is calculated. Maybe they have a new way of thinking about annual recurring revenue, or ARR. In the old days, this would mean a massive, painful backfill project that could take months.
With functional data engineering, this isn't a problem. It's an opportunity. You just create a new pipeline, let's call it ARR version 2, with the new rules. You rerun it across all of your history, and instantly you have a complete second version of history. And the best part, you can compare V1 and V2 right next to each other. No data is ever destroyed, it's just augmented.
So let's zoom out one last time. What does all of this really mean for the future of data? It means data is finally catching up to modern software development.
And this quote from Maxime Bokeman just says it all. For years, DevOps was bringing all this speed and reliability to software, but data couldn't get on board. The underlying systems were too rigid. As he says, the ticket was too expensive for their cargo.
But by embracing these principles, reproducibility, recomputability, this new paradigm might just be that ticket. It gives data engineers the peace of mind they've been craving for years, the ability to build with confidence, to fix errors without panic, and to adapt to business changes with actual agility. So is this how data finally catches the DataOps boat? After everything we've just seen, the answer is a